In this video, we're going to talk about sine rule proof. So the sine rule proof is normally done for two forms of triangles. So we normally do it for an acute triangle and an obtuse triangle. So this is assumed to be an acute triangle and this is an obtuse triangle. In case you are not really sure what the meaning of an acute triangle is and an obtuse triangle is, an acute triangle is a triangle where all its angles are less than 90 degrees. While an obtuse triangle is a triangle where one of its angles is greater than 90 degrees. In this case, the one that is assumed to be greater than 90 degrees is this one. So for this proof, we'll be dealing with the acute triangle first. So to start off, we have to divide this triangle into two. Now I want you to note something. If this triangle is labeled A, B, and C, and these are assumed to be the angles inside the triangle. So this is angle C, this is angle B, this is angle A. So that the opposite side is B, and then the opposite side of angle C is C, and then the opposite side of angle A is A. If we split this triangle into two, we get a right angle triangle here. I'll get a right angle triangle here. So call the height of this triangle H. We can always get the value of H by using SOHCAHTOA because we are dealing with a right angle triangle. Remember, sine of theta is equal to opposite over hypotenuse. So if you are taking sine of B here, it becomes sine of B be equal to the opposite of this angle is H, right? So this is H, and then the hypotenuse is C. So this is C. Now this implies that H is equal to, once we cross multiply from here, we get C sine B. We can still get H from this other side of this other triangle. We know that sine C is equal to H over B. So we can see sine C is equal to H over B. And this implies that H is equal to, because multiply as we did before, B sine C. Remember, H is equal to H, of course. So you can equate this and this to give us something like C sine B is equal to B sine C. We can definitely divide both sides by BC. We can divide both sides by BC divided by BC. We get C cancelling out C here and B cancelling out B here. So that we have sine B over B is equal to sine C over C. If we had cut this triangle from this way and done it another way, we'll get sine A over A is equal to one of these terms here. So it depends on where we cut it from. So therefore, this by extension is equal to sine A over A. So that's how you prove sine rule for an acute angle. Let's clean up the space. For an obtuse angle, you still need to make this obtuse angle look like a right angle triangle too. So I'm going to add up an imaginary triangle here. So I'll call this height H. And then remember, here to here is what? A. And then here, the opposite of it is C. And then here, the opposite of it is B. So this is a right angle triangle. Now I have two triangles, if you notice here, two right angle triangles. This little one here and this bigger one here. So if I'm taking note of the smaller triangle, I could say the sine of, remember this is a straight line, and if this is angle C, that means this is 180 minus angle C. So I can say the sine of 180 minus C is equal to, the opposite of this is H and the hypotenuse is B. So this is H over B. Now there is a rule that states that sine 180 minus c is still equal to sine c. So that means sine c is equal to h over b. So from here we can cross multiply, and then our h will become b sine c. If we are taking note of the bigger triangle, it will now be sine b. Remember, we are taking note of the bigger triangle from here on like this. So it's now be sine b, the opposite over the hypotenuse. So the opposite is simply h over c. So if we cross multiply from here, we have h is equal to c sine b. So the same thing that we did before, we can equate values of h to each other. So this is sine b, c sine b is equal to b sine c. So you can divide both sides by cb. So if we divide both sides by cb, so c cancels out c, b cancels out b, so that we have sine b over b is equal to sine c over c. It depends on where we cut this thing. So by extension, this is also equal to sine a over a. So that's how you prove the sine rule for acute triangles and obtuse triangles. Thanks for watching the video. If you liked it, leave a thumbs up, share with your friends, and subscribe to the channel. Thanks again.